Okay, this is the first of a couple of these where I show you another way to shift your coordinate system in a different world. What I have here is a picture that I've brought into this program called Geometer Sketchpad, which is just this nice, cool little Photoshoppy slash mathy slash whatever else, where all of a sudden you can shift your coordinates, your scale, shear, all these different things. And in this case, I'm not going to even do numerics on this. I'm just going to kind of show you the sense of that idea of spinning circles. So right over the top of this, we don't necessarily have a scale, but we could get this thing to scale X and Y, etc. But we have the ability to shift around our coordinate system. As easy as that. So if we want to shift from there, and again, this wasn't to scale, we can stick a point right there, and we can measure the coordinates of that point. Same thing, we can go back to here and select, and we're not going to do that, but that's the kind of, this is a software push down K-12, and you do a lot of picture stuff, so we're going to try to do some of this and give you the ability to do it with some of your bridges if we've got some decent photos here. I don't think it works with video, but again, measure. I've got more than one thing grabbed there. If I measure that, I've got the coordinates of that point. But instead of that, let's just draft in the right direction this force. There's one force. And let's just draft in the right direction this force here, and it's relatively in the right direction. And let's look at the comparing of circles. Well, if this is a force, we know its moment arm is going to be perpendicular to that line of force. So I'm going to actually go ahead and draft like you know how to do mathematically. I'm going to draft an infinite line along these two. And I can take that infinite line so we don't lose it. I can change it to dotted. Okay, so there's my line there, and we can eventually put a little arrowhead there. And that, of course, is this direction going up this way. This is a reactive force. We can do the same thing here. Draft a line over the top of the applied force, and this time it's remembering a little bit better. And we can see right away our applied forces are not perpendicular. Well, amongst the things we can do, I think, is construct, can't do that. We can construct parallel lines, but instead of that, I'm just going to move this a little bit so we can see that they're parallel. Now, what you need to see, basically, depending on where this is at, if this force is over here, most of the reaction is going to be on this support. If this force is over here, like it is, it's all going to be more on this other one. So I'm going to see if I can finally get these things a little parallel here. Now, we can also construct then between this point and this line a perpendicular circle. Construct, it won't give you any commands until you grab the point and the line and you construct a perpendicular line. And I can do the same here. I can grab this point here and this line here and construct a perpendicular line. And now we see actually they're pretty good. Now on that perpendicular line I can, zooming in here, I can put a point. Kind of hard to see it, but when it'll highlight two of them, right there it's at an intersection point. And now I can draw a circle, hopefully to that point. And I'm just going to, that of course, this, as I go ahead and do this force, you can see that that moment arm is changing. Right? That moment arm is changing. Now at the same time, I can draw a circle between that line and that by first drawing a intersection point right there, and then drawing a circle from there to that intersection point. And remember, this direction here was defined by the boundary conditions. This direction here is defined by the force, right? And its location actually is even defined by the force. So as you shift these things around, right, you can see that in all reality it is going to be this perpendicular line times the length of this force gets me that moment, and this perpendicular line times the length of the force gets me that moment. But all of a sudden, what if that is no longer, what if we're shifting back and forth? You're going to see how that circle's changing as well. So this is the way, when we really think about it in terms of the lever rule, of looking at the magnitude of force and then comparing the circles. Again, this does not get you out of doing R cross F, but this is how one can very quickly add together three forces. Put one here. Let's say that's a force, and this is a force, and this is a force. If those are three forces, you can add them together by sliding, and then eventually you have to go and do some of this stuff in Geometer Sketchpad. No, I'm sorry, on a sheet of paper. So this concept here, that we can take this, copy, paste, right? Can we do that? We can't do that. What we have to do is we have to get this line along here and along here. So you just can't pick up and move vectors. You can only slide them back and forth. And then once they have a common concurrent point, then you can do your addition. Realistically, the sum of R cross F does it for you. And in the end, you have to put all these vectors back to do your calculations on the structure itself, which is what we'll look at with your bridges and with other structures. So this looks like a bunch of hobbly-podge, and it a little bit is, but I just showed you, I wanted to show you an output from AutoCAD. This picture here was, of course, a JPEG, a PNG out. I could edit the things out in the back. I could take the background out, all kinds of different stuff. So plotting to a PNG, and in the end, you can do all kinds of other things when you get software working together. Put a circle there, and I'll just take this point right here, I'm shifting the circle, and now I can, I think, merge the point to the circle. And now I can take that point and animate it. Let's see what happens. Got a lot going on. This is what you see when you start doing coordinate transformations in terms of skew for photos. This is the kind of morphing that goes on. Now that's just one circle going around in three ways, going very slowly because that picture is hard to move. I'm going to go ahead and stop that. Put another circle up here at the other corner of my picture. And what I'm doing here, again, this has got a bit of a learning curve, but it's a fun learning curve, and it's going to be great for those with kids, I would say. And now this time I've got 2 points. That point, and I gotta believe that point, and I'm going to animate them both. So right there is your coordinate schist. There's a lot of matrices going on. It's machine design. It's all kinds of other stuff. But this concept of how much the circle comes in to the basics of a lot of this mathematics is important for us to know when we try to learn, of course, 1, 2, 3, 1, 2, 3, square root of 1 is 1, square root of 2 is square root of 2, square root of 3 is square root of 3. The circle keeps coming back. It keeps coming back. So anyway, I'll push this one out. Probably no one should watch it too much, but what I'm trying to do is get you to the point where you can add your vectors by sliding and then do reactions very quickly, very efficiently by paper, and then realize that's what's going on in the software. Thanks for listening.